My name is Professor Rad, and this is Precalc video 313, sinusoidal graphing with a phase shift this time. So this is a continuation of the last several videos that we've been looking at. So if you haven't watched those yet, you want to watch those first so you know where all of this information is coming from. But I've got some formulas written on the side here. So our sinusoidal functions look like a sine omega x minus phi, or a cosine omega x minus phi, where omega has to be a positive value. And then we have formulas for our amplitude, the period, the phase shift, key points, and then we have our base functions sine and cosine. So we're going to start out this example, in this video, we're doing one example. This example is to graph g of x, which is 3 cosine of pi over 6 minus x over 2. So we're going to start out this example by summarizing some information, writing down a, omega, phi, all that good stuff, figuring out the amplitude, the period, the phase shift, the key points, and so on. Once we have all of that information, then we know how to label the horizontal and vertical axes, and then we can finally graph. So to start out with, I do notice there's a little problem with this function, and that is that the coefficient of x is negative. So we're going to have to rewrite this so we have a positive omega. So we're going to start out by rewriting. Remember that cosine is an even function. So cosine of negative theta is the same as just cosine of theta. So I can take this expression, 3 cosine, let's factor out a negative. So we would get negative pi over 6 plus x over 2, factor out a negative. And because we're even, we can just drop that negative. So this will be 3 cosine of negative pi over 6 plus x over 2. And then lastly, I'm going to rewrite this in a way that's going to help me out. So I'm going to write this as 3 cosine of, instead of x over 2, I'm going to write that as 1/2 x. And then I'll write minus pi over 6. So this way I've accomplished 2 things. First and foremost, I've got my x value first, so I look more like my standard form. And I've got a positive value for omega. And I've got that 1/2 written so that I know that omega is 1/2. I don't have to worry about trying to parse that out from x over 2. So speaking of, let's find a, omega, and phi. So a is the coefficient of the whole function, so that's going to be 3. Omega is the positive coefficient of x, so that's 1/2. And phi is the value that we are subtracting. So we are subtracting pi over 6, so phi is pi over 6. So also remember that when you're identifying phi, you want to use the opposite sign that's being used in the parentheses, because horizontal transformations work the opposite the way we want them to, and that's going to be a problem that continues to plague us now and forever. So if you want to take a moment and review, go ahead and apply these 4 formulas, the amplitude, the period, the phase shift, and the key points. For each of these values, you can now plug those into those formulas. If you want a bit of review, I'm going to walk through them now. So our amplitude is going to be the absolute value of A. So the amplitude is going to be the absolute value of 3, which is 3. This is going to help us to determine how we label the y-axis. So the amplitude is going to be important both when we graph and when we scale this vertical axis. Next, for the period, we're going to get 2 pi over omega. So omega is 1/2. So we have 2 pi over 1/2. So when you divide by 1/2, that's like multiplying by 2. So we'll get 4 pi. Next, for the phase shift, we have phi over omega. So phi is pi over 6. And we're going to divide that by omega, which is 1/2. And as before, dividing by half is the same as multiplying by 2. So that's going to give me 2 pi over 6, which is the same as pi over 3. And lastly, we have our key points. And this time I'm going to use the t over 4 formula, just because omega is a fraction, I don't want to deal with it. So for my key points, I'm out of room, so I guess I'll write it here. Key points. That's going to be the period of 4 pi over 4, which is the same as pi. All right, so that's finding all of that good information. Whew. Now that we have that done, we can go ahead and label our horizontal and our vertical axes. The y-axis is always easier to label because it's just based off of your amplitude, and usually there's no pi involved. So our y-axis, we have to go at least up to 3 and down to -3. So I'm just going to count by ones, 1, 2, 3, 1, 2, 3. Next, in our last video, we used the key points to index our horizontal axis. So we would count by pi for each of these. However, this time we have a phase shift. So when you have a phase shift and key points, right? So really when you have a phase shift, because you're adding that in, you need to take both of these into consideration now. So typically the way that that's going to work is you want to find a common denominator for both your key points and your phase shift. So in this case, my phase shift is pi over 3, and my key points are going to be every pi, so I can think of it as like pi over 1. So the common denominator here is going to be thirds. So I'm going to use pi over 3 to label the x-axis. This is because the shift is pi over 3, and my key points are going to be every pi, which is the same as 3 pi over 3. So when I'm labeling my x-axis, I want to be able to take into consideration that I'm going to have to shift this by pi thirds, and my key points, I'm going to index them by thirds. So what that means is instead of counting like one line over to plot my key points, because I have 3 pi thirds, I'm going to count 3 tick marks to plot my key points. So let's graph the horizontal axis first. I'm going to use pi over 3 for each of these intervals. So this is 1 pi thirds. This is 2 pi over 3, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds, 7 pi thirds, 8 pi thirds, and so on. So that's how I'm going to be counting. Now, if you want to simplify, you could reduce this to be 2 pi, just 2 pi if you wanted to, but I'm going to keep them in terms of pi thirds, just as a reminder that that's how I'm counting. And I'm going to do that going to the left as well. So this is 1 pi thirds, 2 pi thirds, 3 pi thirds, 4 pi thirds, 5 pi thirds, 6 pi thirds, 7 pi thirds, 8 pi thirds, and so on. So that's how I'm labeling my horizontal and my vertical axes. Next, we are graphing a cosine function. So for the cosine function, I need to know where that starts. So the cosine function usually starts at the point 0, 1. So I know I'm going to be starting with that point, the one that's at the top of my cosine curve. Instead of 1, I'm going to use 3 because my amplitude is 3. And instead of 0, I'm going to use pi thirds because that's my phase shift. So the point that I'm going to start at is going to be at pi thirds and 3. If I were graphing sine of this instead, so if I had 3 sine of this, then I would be starting at pi thirds 0 because the sine function starts at 0. But because the cosine function starts typically up at 1, I want to make sure I'm starting at that high point. So I'm going to go to 1 pi thirds and go up to 3, and that's where I plot my first point. To figure out where I get my next set of key points from, I'm going to use what I wrote down here. So my key points happen every 3 pi over 3s. So I'm going to count 3 tick marks, 1, 2, 3, and then I plot my next key point. And if I check this against what we found was pi, right? So from 1 pi thirds to 4 pi thirds is a distance of 3 pi thirds, which is 1 pi. So that's my unit that I'm going by. So then I'll plot my next key point by going over 1, 2, 3, and then this time down to -3. 1, 2, 3. Now I'm out of space to the right, so I'm going to plot key points going to the left. So 1, 2, 3, here at 0. 1, 2, 3, down here at -3. 1, 2, 3, here we are at 0. Then I'm going to go ahead and connect the points in the standard sinusoidal shape here. So there you go. That's how we graph our sinusoidal function with the phase shift. So that's going to wrap it up for this video. We're just going to do that one example. In the next video, we'll do a second example of graphing with a phase shift, because I know that that's a lot of information to keep in mind. So we'll definitely do another example with a phase shift. And then of course, we'll just add on just one tiny little layer of complexity to that one too. So I hope this helped you to graph a cosine function with a phase shift. I will see you again in the next video. And in the meantime, I hope you have a magnificent day. Bye for now.